math students. This is Dr. John, your professor, to help you with rational expressions. I'm giving you a variety of exam questions from grade 11 pre-calculus course, and we have a whole bunch of these. I'm going to do several of these in the next couple of videos, how to simplify each expression and state any non-permissible values. This is a common exam question. Here we have one rational expression. A rational expression is just a ratio of two different expressions. In this case, they're polynomials. And this is divided by another rational expression. When we do things like this, you'll often want to say, is there a way that we can cancel something? To cancel, we'll have to see if we can factor these. So I'm going to do these one at a time. Let me write this one up here from the bottom there. Let's see if we can factor it. We're just going to use the brute force method. We know this has to be an x, this has to be an x. Since they're both positive, it'll have to be positive. Now, what is it that multiplies together to give you 12, but adds up to 7? Well, that would be 3 and 4. Let's check. This is 12, this is x squared, 3x, 4x, 7x, that works. I'll take this factored form, write it down here just so we have it as a reference. I wrote the factored form of this over here, and just to take it as the next step, wrote this one up here so that we can look to see if we can factor this. Let's use the same brute force method. We know this has to be an x and an x, and since this is negative, one will have to be a positive, one will have to be a negative. Doesn't matter which, because these are identical. Now, what is it that multiplies together to get you minus 12, adds up to get you 4? Well, it can't be 12 and 1, so we have 12 and 1, minus 12 and 1. It won't be 12 and minus 1, so the next ones are 3 and 4, which this could be minus 3 and 4. This would multiply to this. This would add up to plus 1, so let's do it the other way around, like that. Now we go plus 4, minus 3. Let's erase this and check this. Plus 4x minus 3x minus 12 x squared. This works. I'll write this down here and then we'll carry out our next step. The next step in this operation is to take all of this and rewrite it, being very careful we're dividing. Whenever we divide a fraction, we have something here and we're dividing it by a fraction, we'll take the fraction and flip it and multiply. That's the very definition of division. I'm going to rewrite this one up here. I've rewritten this first one over here, up here, but written down the factored form. Now I'm going to say it's going to be x plus 4, x minus 3, and this one here is going to become the bottom. So I'll put this over there, 2x minus 1. There's minus 1. They just can't be factored in any way, so we'll just leave it as it is. Put brackets around it. If we have brackets around everything like this, we can just put this all together and make it all 1. We don't have to put a big x in there as a times. If you do that, it's confusing anyway, because it might be, you might think that that's another x. So now we have this all written down. We've figured out the division. We've done all the factoring. Let's see if there's anything that cancels. Well, we see this obviously, this one and this one. This one is minus 3. This one's plus 3. So let's write the answer down for what we have here. We have 4x minus 1. That's in the top. X minus 3. That's in the top. All over. I'll write this over here just so we have it right underneath this one. And then we'll put this one over here, 2x minus 1, just so it looks symmetrical. Here we have the answer for this written. Next, we're going to take a look at what values might be non-permissible. When we're doing the non-permissible values, there's a couple of things that we need to keep in mind. First of all, we'll look at each of the numerator and the denominator, look at each of those and see if there's anything in there, like for example, a tangent function or a square root or something that might have limits on what x you can put in there. Well, since these are all polynomials, there's no limit on the x values that you can put in there. So that's eliminated. We've got that taken care of. Next, we look at the denominator. But in this case, it's sort of special because we have a number of different denominators. We have this denominator here, which is the same as this. We can just look at this one, the factored form, just as good. We have this as a denominator for this and this. But also, when you flip this, you're going to have this as a denominator as well. So you have to watch out for that as well. So here, obviously, we're not allowed a couple of values. X cannot equal minus 3. That's for this one. And it cannot equal minus 4. That's for this one. Can't also equal 3. So I can make this a plus or minus 3 for this one. But when there's one more value here, and that is this thing here, because you're going to flip this, we're going to put that into the denominator later. This 2x minus 1 also can't be equal to 0. 2x minus 1 equal to 0. 2x equals 1. X equals 1/2. So x cannot equal 1/2 because if it is, then this is equal to 0. So also 1/2. So these are the 1, 2, 3, 4 non-permissible values. When you're finding those, always look at what's in the denominator, and also if you're doing some operation or you're making a pathway from here to here, check everywhere along the path as well as your final answer. I hope that helped. If it did, check out my next video. I'll see you in a minute. Bye-bye.